Well, now we will see a series of different examples in which we will outline the difference among the different pressure vessel standards and the pressure vessel materials. First of all, let's take this file, R001. This is not a vessel, this is just a cylindrical shell. If we want to see it a little bit better, we will change the position and the perspective view. And so you see that this is our shell. Let's see the properties of this item. The pressure vessel standard used is ASME 8 Division 1 Edition 2023. The materials will be carbon, manganese, silicium steels, taking the characteristics materials that are used for this standard, ASME 8 Division 1. Then let's give a look to the design conditions. The temperature, design temperature is 150 degrees. The pressure, the design pressure is 1.5 megapascal. That means 15 bar. The joint efficiency is 0.85. The corrosion allowance is 1 millimeter. Well, now let's open this file. And we will give a look to the general characteristics of this shell. It has a length of 6 meters, a diameter of 1.5 meters, and a thickness of 11 millimeters. Let's look at the preliminary report. The preliminary report says that the minimum required thickness is 0.68 millimeter. That means that 11 millimeter is sufficient. So we confirm, and then we will look at some properties. For example, the weight. The weight of this shell is 2,428 kilograms. If we want to make some kind of comparisons, let's open a file here. This is an Excel file in which we will write for all our examples the different characteristics. So, for example, you see that thickness is 11 millimeter. This is the first example. And the weight is 2,428 kilograms. Now we'll leave this here just for further checks. And we will take now, close this file, close item, and we will look for another example. We take this other item, R002, small adjustment to see it a little bit better. And let's look at the characteristics. In this case, properties. The pressure vessel standard is now ASME 8 Division 2 Edition 2023. This further addition of Class 2 is not needed in the further edition of the ASME code, the edition 2025, where only one series of nominal design stresses, the stresses of the old Class 2, has been considered. The design conditions are always the same. And now let's open this shell. You see that now the thickness is 10 millimeter. Why? Let's give a look to the preliminary report. The preliminary report says that we have a thickness of minimum thickness of 9.66 millimeter. Just one small, so the 10 millimeter adopted is perfectly adequate. Only one small remark: the under tolerance is 0, as it was already also in the preceding file, because according to the ASME code, the tolerance, if it is lower than the minimum value between 6% of the thickness and 0.25 millimeter, has not to be considered. Well, now we confirm this. We look at the properties. We see that the weight is now reduced because we have reduced the thickness, so the weight is now 2,206 kilograms. We update our shell file, thickness 10 millimeter, and weight 2,206. We leave this for further comparisons. We close this item and we will open a further item. We open the item R003, where is it? It's here. Also in this case we make some kind of adjustment of the image. Now it's much better. And we look at the design conditions, properties, better at the properties. Now the code is not anymore an American standard, it is a European standard, the harmonized European standard for pressure vessels. ENG 13445, edition 2021, issue 1. What is characteristic here is that, of course, the dimensions are always the same: 6 meters and 6 meters length, 1.5 meters diameter. The under tolerance now has to be considered as 0.3 millimeter, and the joint efficiency is always 0.85. The material, while in the preceding two examples we have used an ASME material SA516 grade 70, now we are using the equivalent European materials P355GH EN 10028 to thickness below 16 millimeter. Look at the preliminary report. The minimum thickness is, the minimum required thickness is 7.98 millimeters. That means that 8 millimeters that have been used are sufficient. So we confirm. We will give a look to the weight. The weight is 1,785 kilograms. We open again our Excel file and we will update it with this data, 1,785. We leave the file open here and we go now to a further example. So we close the item and we will open a further item. R004. We adjust the image a little bit. And look at the characteristics, properties. Now The design standard is VSR revision 1995, which is the UNI PDR 55 of 2019, and therefore the characteristics are always the same as the preceding example. Look at, we open this shell, we will see that there is always the same under tolerance, the same dimensions are always the same. The material is always P355GH, so the same material as the preceding example. The nominal design stress is always the same, because the nominal design stress is the yield point divided by 1.5, basically. So we do not expect to have a big difference in respect of the preceding example. In fact, the minimum required thickness is always 7.98. The 8 mm are sufficient. Therefore, we close this. But before closing, we should give a look to the weight, but in this case it's not necessary because the dimensions are always the same. The thickness is 8 mm and the weight will be certainly the same, 1785. So we'll leave this here for further checks. We open a further item in which again we have changed the design code just to correct a little bit the image, and then we will see the characteristics. What is now changed is the design code, which is the German pressure vessel standard AD 2000. Note that in this particular case, the preliminary report is this one, we get always the same thickness, but really this is because the temperature is 150. With a lower temperature, maybe we could have an advantage on the design stress and on the thickness, because in the German pressure vessel standard we have seen that there is no correction for the tensile strength at relatively low temperatures. The nominal design stress is always, as in the Italian code and as in the harmonized standard, the yield point divided by 1.5. We close this. We make a further correction to our Excel file. 8 mm is always the same. The weight is always the same. We leave this for further check, and we close this item. We take this R006, small adjustment of the image, and then we look at the characteristics, properties. The design standard is again ASME 8 Division 1 Edition 2023. What is changed now? Now we look here, we open the input file, we see that the material is changed. The material is not an ASME material, is a EN material, but the version of the EN material which has been considered by the ASME code in Part 2, Section D of the standard. You see that there is a symbol SA preceding the symbol of EN, and what is characteristic is that the thickness is lower than 60 mm, while in all the other examples made with the European pressure vessel standards, the thickness was below 16, but this is due to the fact that in the ASME database there is no possibility of considering thicknesses lower than 60 millimeter. Therefore, the result is not very favorable, because we close this database, we look at the preliminary report, you will see that the thickness is 10.14 millimeter. That means that 11 millimeter are always necessary, as with the use of the ASME materials. Therefore, we have to close this, updating our Excel file with the characteristics of the preceding example. 11 millimeter thickness, 2,428 kilograms. We leave this file here. We close this item, and we will look at a further example, R007, in which the design standard is changed again, because the design standard is ASME Division 2 edition 2023. What is changed? As in the preceding case, the change is the material. The material is again the SA EN 10028-2 material, but now we have the thickness below 16 millimeter. Why? This is because in the database now, only for Division 2, all the thickness classes contained in the European standard have been considered: 16 millimeter, 16 to 40, 40 to 60, and so on. The result is the preliminary report. The minimum required thickness is 7.37, so 8 millimeter is sufficient. Note that the under tolerance is 0 for the same reason as that we told before, that in the ASME code the under tolerance of the plate must not be considered in case this under tolerance is lower than the minimum between 0.3 millimeter and the 6% of the thickness. Therefore, we update again our Excel sheet. We have already the case of 8 millimeter, which gives a weight of 1,785. We leave this for further check. We close this item, and we open a further item, R008, which is always the same shell, but with some changes in the standard and in the material. To look at the changes, first of all, item properties. The standard is now again EN 13445 3 edition 2021, and the material is now an ASME material, SA 516 grade 70. In this case, the thickness has to be considered. The thickness given by the standard is 0.25 millimeter. Note the small note here, PMA, Particular Material Appraisal. What is the meaning of this note? That it is necessary to have from the material manufacturer the assurance or the guarantee that the hot tensile properties is considered by the ASME code are acceptable for him. and so he is able to guarantee these
hot tensile properties.
What is the reason of this? The reason is that the standard, the original standard 516 grade 70 doesn't contain characteristics at temperature. It contains
Only
characteristics at room temperature. The
hot tensile properties
are given only by the ASME code, but this is not a guarantee of the manufacturer, because there is always a note that these
hot tensile properties
are recommended, but they should not be the subject of a tensile test to see that these stresses are met. Let's look at the preliminary report. The preliminary report is gives 9.87 millimeter, therefore 10 millimeter is enough. There is, however, a warning, a yellow warning. Let's look at the warning. The warning says that selected material belongs to material group 11.1. No rules are given for this group of material. Why? Because in the original specification, the chemical analysis is outside the rules given for the normal carbon steel materials. However, this is just a nominal problem, because all the steels, whichever is the standard and wherever they are fabricated in Europe, in the States or in China and so on, have the carbon content below 0.25, which is not the case of the standard A516 grade 70. Therefore, in our case, this note is not important. We confirm this and we give a look to the weight. The weight is 2,206 kilograms, because the thickness has been reduced again by 1 millimeter to 10 millimeter now. So we update our Excel sheet. 10 and 2,206. We leave this further open. We close the item and we close also the presentation, in the sense that you have seen how the weight, the thicknesses and the weight may vary, changing either the design standard or the material used with this design standard. With this, I have finished, and I thank you very much for your attention.